The next problem says Atilkas is in a rowboat 3 miles from a straight coast. He wants to go to Boo Radley's house 2 miles down the coast. He can row 4 miles per hour and jog at 6 miles per hour. Where should he land on the coast in order to arrive at Boo's house in the shortest possible time? Since it says shortest possible time, that's my keyword. That means that I need to take the derivative of time. So I know that I'm going to have a time equation. And the only thing that relates the distance, the rate, and the time would be the distance formula. So I know that I'm going to have a formula that has time is equal to d over r. So basically what I have is he's going to row this amount of time, and he rows at 4 miles per hour. Then he's going to jog from this point to Boo Radley's house, and he's going to jog at 6 miles per hour. And we want to know where should he land. So we want to find this distance, which we're going to call x. So the time equation is going to be when he can row plus the time when he can jog. So the distance when he's rowing over 4 miles per hour, because it's distance times the rate, plus the distance when he's jogging over 6. So we need to find the distance of his rowing and the distance. So we need to find the distance when he's rowing and the distance when he's jogging. So this is the distance when he's rowing. So I need to be able to write that in terms of one variable. So I'm going to be using x. So I can use the Pythagorean theorem since this is a right triangle. So I'm going to have 3 squared plus x squared is equal to 4 squared. So 9 plus x squared is equal to 16. So x squared is equal to 7. So x equals the square root of 7. So I'm going to use the Pythagorean theorem to find this distance, and this is we're just going to call the distance of his rowing. So the distance of his rowing squared is equal to 3 squared plus x squared. So that's going to be 9 plus x squared. So his distance of his rowing is going to be the square root of 9 plus x squared. So that is this distance right here, square root of 9 plus x squared. So the next distance that we need to find is the distance that he's going to jog. So it's going to be from this point to the house. So we do know that his Boo Rose house is 2 miles down the road. So that means this whole distance is 2 miles. So the distance that he's going to row or jog would be 2 minus x. So his time equation is going to be the square root of 9 plus x squared over 4 plus 2 minus x over 6. And I'm just going to rewrite this as 1/4 square root of 9 plus x squared plus 1/3 minus x over 6. So what I did here is I just reduced 2 6 to give me 1/3 and then negative x over 6. So if I take the derivative, because I'm trying to find the shortest possible distance, so I'm trying to minimize the distance. All right, so my derivative is going to be 1/4 times 1/2 9 plus x squared to the negative 1/2 times the derivative of the inside, which is 2x. derivative of 1/3 is 0, and the derivative of x over 6 is just negative 1/6. So I have my 2's here, they're going to cancel, so I'm left with x over 4 square root of 9 plus x squared minus 1/6. So I'm going to set that equal to 0. And if I add 1/6 to both sides, I'm going to go ahead and cross multiply. And then I can take the square of both sides to get rid of the square root. So I get 36x squared equals to 16. 9 plus x squared. So if I divide by 16, get 9/4 x squared. Subtract x squared. I'm moving the x squared to the other side. I'm subtracting from both sides. So I get 5/4 x squared is equal to 9. So if I multiply by the reciprocal, I get 36 over 5. So x is approximately 2.683 miles. So once we have our answer, we always go back and read the question to make sure that we answered it correctly. So the question is, where should he land on the coast? So he should land approximately 2.6832 miles. The next question says, we're going to approximate the square root of 35 two ways. First, we're going to use linearization, and then we're going to use Newton's method. So let's start with A. We're going to use linearization. So they tell us we're going to use the linearization of y equals the square root of x at the point 636. So remember, linearization is just another way of saying find the equation of the tangent line of y equals the square root of x at 6 equals 36. So to find the equation of the tangent line, the first thing I need to do is I need to take the derivative. So the derivative is going to be 1/2 x to the negative 1/2, or 1 over 2 square root of x. Now I'm not going to set that equal to 0 because I only do that when I'm trying to minimize it, when I'm trying to find the max or the min value or the critical points. So what I am going to do is, since this is my x value, I'm going to go ahead and substitute my 6. So before I substitute, remember that I told you to change this. It should be 36 comma 6, not 636. So if I substitute 36, I'm going to get 1 over 2 square root of 36, which is 1 over 2 times 6, or 1/12. So then, once I have my slope, remember this is the slope of your tangent line, I have to use point slope form to find my equation of my line. So I'm going to have 1 over 12x minus 36 over 12, which reduces to 3. I'm going to add 6 to both sides. So here's my linearization. So I'm going to use that to approximate the square root of 35. So I'm going to say let x equals 35. So my my linearization at 35 is going to be 1 over 12, 35 plus 3. And that's going to be 5.917. Remember to always round it off to 3 decimal points. So that's what I think the square root of 35 is. So if we use our calculator to find out the square root of 35, so using our calculator, the square root of 35 is 5.916079. So we're really close, so that's how we can check to make sure that we did this correct. The second way to do this is we're going to approximate the square root of 35 by using the first guess of 5 and 2 alterations of the Newton's method to approximate the zeros of f of x equals x squared minus 35. So remember Newton's method is we need the derivative. Newton's method says that you're going to approximate using the next alteration is x of n minus f of x of n over the derivative. And we only need to do 2 of these. So x of n, let's write f of x of n, f prime of x of n, and then the minute guess. So they said to use the first guess of 5, and we're only going to do 2 of these. So as we substitute 5 in here, we get 5 times 5 is 25, and 25 minus 35 is negative 10. That's using x squared minus 35 here. So 25 minus 35 is negative 10. F prime would be 2 times 5, which is 10. So my next guess is going to be 5 minus negative 10 over 10, which is going to be 5 plus 1, 6. So 6 is going to be my next guess. So as I substitute 6 here, I get 36 minus 35, which is 1. If I substitute 6 into the derivative, I get 2 times 6, which is 12. So now I'm going to have 6 minus 1 half, which is 5.5. Let's do one more, 5.5. So I'm going to put 5.5 squared minus 35. That's going to be negative 4.75. And 5.5 times 2 is going to be 11. So I'm going to have 5.5 minus a negative 4.75 over 11. So my new guess would be 5.9318. Make sure how many alterations did they want me to do. They wanted me to do 2. So I did 3 just because 5.5 wasn't close to my actual value. So if I do 3 alterations, I get 5.9318.